So with graphing quadratic word problems, it's the same scenario every single time. A ball getting kicked, something getting thrown off a cliff, something that's making this like U-shaped graph. You good, Jordan? Where it's going to make usually an upside down parabola. We're never throwing something that's going like up, right? So for example, this one, so with this scenario, this one's showing you a cannonball being projected out of a cannon, and it's saying it's being fired from a cannon, and this is the path of the cannonball. So it shows you getting shot, it gets up, and then it falls and hits the ground, right? And it's saying that this is in time seconds, and height is in meters. So if it's asking, what is the maximum height reached by the cannonball? Well, I can refer to the vertex. This is my highest point. This is the highest it will ever go, right? So this is my max height, right? So we can say, therefore, the max height is 70 meters, right? So it's wherever your vertex is. So this is your vertex Y value if it's asking you about the maximum height. If it says, when did it reach maximum height? When did it reach 70 centimeters? That's when it's talking about the X value of your vertex, right? When does it hit its maximum height? What's the X value of the vertex? What's the X value? 6, which if we're talking about time, this is after 6 seconds. It will hit its maximum height at 6 seconds. That's it. There's no trick questions. It's literally just now taking your data or like a point on a graph and putting it in terms of like distance or height and seconds for time. Right? So that's our vertex. If it's asking how high was the cannonball above the ground when it was shot from the cannon, that's like what was our starting point? Yeah, Anna? Exactly. This is our y-intercept, right? This is our starting point, or where it's being launched out of its cannon, right? So it was 7 meters off the ground. So maybe it was on a platform, maybe it was like out of a window in a building. We don't know what the scenario is. But it was 7 meters off the ground. Yeah?
Is this test is going to be 4.4?
Mm-hmm. Thank you. Perfect. And then same thing, how long did it take for the cannonball to fall to the ground? Well, how long was it in the air for? When does it hit the ground? When does it hit the ground? Yeah, maybe you should take the AirPod out so you can hear. Right? After 12 seconds. This is when it hits the ground, right? You can think of your x-axis as like the ground here in this scenario. So it takes 12 seconds. It takes 12 seconds to hit the ground. Right? Anytime it's talking about hitting the ground, whether it's a ball, a cannon, somebody hitting water level, that is always talking about your x-intercepts, right? And then lastly, they want to know what's the equation for the pathway of this cannonball, right? What equation models this? Which we know vertex form, so I would say step 1, start with your general equation, right? Ax minus h squared plus k. I would know this for your test on Friday, all right? Then step 2, plug in your vertex. We know what the vertex is, so we can just replace that for h and k. Right, so what is my h going to look like? This is going to be x what? I'll zoom out. It looks like I've shifted 6 units right, or I'm starting at 6 seconds, right? That's my vertex. So is this going to be minus 6 or plus 6? Minus 6 squared, and then plus my height, so plus 70. Right, so I've got that, but I have an a value. Like, we can't just leave it and say it's x minus 6 squared plus 70. We need to know what a is. Is it vertically stretching? Is it vertically compressing? It looks like it's flipped upside down, so it should be a negative value, but we just don't know what it is, right? And maybe with a big scale, I can't count step pattern and be like super accurate. So I can pick any point on this graph, any point, and like we'll plug it in for X and Y. I'm going to choose our y-intercept since it's like perfectly there and defined for me. But you could choose any point. So step 3 is plug in y-intercept for X and Y. So this would look like my y value is 7 and my x value is 0. Which I'm just going to continue this up here because I used a little bit of space. Right, so that coordinate point, my y-intercept is 0, 7. Hence why 0 was for x and 7 was for y. And then I'm just going to solve. So this is going to be 7 equals 0 minus 6 is just minus 6 squared plus 70. What's negative 6 squared? Do you remember that? Negative 6 squared? Negative 6 times negative 6? 36. So this is 36a plus 70. And I want a by itself. So what's my next move? What do I got to do?
Minus 70.
I got a minus 70 on both sides. So this is going to give me negative 63 equals 36a. Ooh. Which if I want a by itself, I just have to divide both sides by 36. Which gives me negative 1.75. So therefore my equation, my overall equation, I'm just going to use like my vertex form. But now I have an a value, so I can say y equals negative 1.75 bracket x minus 6 squared plus 70. And that is your equation. So if you plug that into Desmos, it would give you this graph here. Right, it'd model it. So step 1, start with the general. Step 2, plug in your vertex. And then step 3 is pick any point. I could have picked this point here. I could have picked this point here. Just pick a nice point where it's clean, no decimals, right? You want it to be super exact, right? How do we feel about that? I'd say that's the only step up, making the equation. It's okay? It's not too bad? Am I okay to flip to the next page? No? Okay, I'll wait. There'll be one word problem on the Friday test, just one.
Like that.
It could be like this. Okay, am I good? Am I good to flip? Okay. And then last one, this one's another scenario, but it's the idea of you're throwing a paper airplane and you throwing it out the window, it's gonna go up and down and it's gonna model a parabola basically. And it's saying to raise money for a charity, a company held a paper airplane contest. The planes were thrown from the roof of a building and the formula for the height and distance of the winning plane was modeled by this formula. H is equal to negative 0.25 and then D minus 10 squared plus 200, where H is the height of the paper airplane in the air, but D is the distance from the building from which they threw it through, right? So again, what is the maximum height of the paper airplane? We're in vertex form, so I can see what's my max height? 200, right? If my vertex is equal to 10, 200, right, because H and K, then my max height is going to be 200. It's the Y value. Is 200 meters.
I don't know if yours.
It says it's meters in here. Yeah, the building in meters and meters. Okay. How far away was the building, or how far away from the building was the paper airplane when it reached its max height? That's just your X value. No, because I saw you making kissy faces out in the hall to your friend. So I know that is not the reason you're going out there, right? So how far away was it when it reached its max height? That's just the X value of your vertex, which is what? What's the X value of the vertex? X value of the vertex. Are we okay today? Dude, stay focused.
I got it.
What's the X value of the vertex, people? 10, right? So it says it was 10 meters away from the building. You don't have to show any work for this other than if you want to state the vertex, right? There's no calculations you have to do. You're just basically dissecting the equation, right? So 10 meters away from the building. And you can even make a note. This is your x value of vertex, right? And this will always be your y value. If it's talking about height, that's your y value. Right? Then it asks you, well, how tall is the building? What is the height of the building that they're throwing this paper airplane from? Right? So it's like, if I want to figure that out, I need to look back at my equation, because this is the height of the paper airplane, and my d variable is talking about the distance that the paper airplane has traveled from the building after I've thrown it. If I'm in the building and I'm holding on to the paper airplane and I haven't thrown it yet, how far has the paper airplane traveled?
0 meters.
0 meters. It hasn't traveled anywhere. So I'm going to replace D with 0, right? So D equals 0. And you can even say, airplane has not been thrown. Right? So I'm standing in the building with it. I haven't thrown it yet. So that will tell me what the height of the paper airplane is. So we're just going to do H equals negative 0.25 times 0 minus 10 squared plus 200. Right? 0 minus 10 is just going to be negative 10. Oop, 200, not 2,000. And now I need to evaluate this. So negative 10 squared. Negative 10 times negative 10. What does that give me? 10 times 10? This one would be positive 100, right? And then plus 200. And then negative 0.25 times 100, what's that going to give me? Who's got the calculator? This is going to give me negative 25 plus 200. So overall, my building is 175 meters tall. Is that okay? So the building height is just in terms of distance. The plane hasn't traveled anywhere, so it's at 0. That's all it's saying. If they specifically tell you, well, what's the height of the airplane when it was 30 meters away from the building? 30 meters away just means D equals 30. So I'm just going to redo these same steps, but rather than plugging in 0, I'm just plugging in 30. Right? So the same thing. Which, when we do that, we end up getting a bigger height. Here. Or a bigger square, I should say. This is going to give me 30 minus 10 is 20 squared. Which, Ethan, you did this question yesterday. What did you get for this one? This one.
Oh, 100.
You got 100. So this gives you negative 100 plus 200, which, yeah, negative 100 plus 200 is just 100 meters. So it was 100 meters above the ground when it was 30 meters away from the building. Right, so word problems, the actual work itself is minimal because you're just looking and analyzing either a graph or an equation, and you're looking at the features. Max height, when is it reaching max height? That's all about your vertex. Hitting the ground is your zeros, and then if it tells you a specific point on the graph, you can just plug that into your equation. So there's nothing really new here that you haven't done already, right? It's just dissecting it. And that is it. I told you, baby lesson. So I'm going to post these questions for you to practice. Notice it's only 4 questions.